So the first thing you'll notice, if you refresh your Dropbox, is there a category up here called Projects. And I've been asked about letting people do projects. I'm giving you an idea for one. If you have your own idea for one, I'd like for you to write it up and submit it to me, and I'll give you an okay on it, and then you can go ahead and do it. So if you want to do the project that I suggest, it's got a long description, but it's not that hard. It's just that it's a long description because it's a set of rules for like a very simple game, but it gets reworded a time or two, and then there's an example of it. So let's go ahead and look at it. I'm just going to kind of give you an overview of it rather than go through and read it line by line. So, the program implements a combat system for an imaginary game called Python Fighter. So what you will do is allow the user to enter the stats, should be stats, not states. I guess technically speaking, a state is a stat, vice versa. And then your output, you should show the results of the battle one by one. An example of this is on page 5. Your output does not have to match it, but should be informative, at least showing the attacks, the real damage, and who lost that round. Okay, so there's a mention of a WPF application there. We haven't studied graphical user interfaces. How many in here are also in the C# class? Nobody? Okay, because they're going to get to do the same project. And certainly that'd make it easier for them if they were doing it in here as well, or vice versa. So how it's graded. If you correctly implement all the rules shown on page 2 and 3, then you get 80%. If you also add a battle history feature as shown at the bottom of the sample output, then you get an extra 10%. And if you add one or more fixes to prevent a never-ending battle, because if you give your characters stats with another armor, they'll just sit there striking at each other and never actually do any damage, and the battle will go on forever. So the way it works is, if you've ever played a game like Dungeons and Dragons or something like that, where you roll dice and you can take hits, you know, it's kind of like that. Or if you've played an online game where you have character stats and your character can take damage, and you know, and things like that, it's like that, except it's really simple. So each character has 4 attributes, 3 of them which affect fighting. They have a name, they have a combat rating, which is kind of their health, they have armor, should be armor, not armors, and attack dice, just regular old 6-sided dice like you'd play in Yahtzee or Monopoly or anything like that. So the stats are used to determine the outcome of a series of rounds. The way it basically works is each one rolls their attack dice. They add a bonus based on their combat rating. The loser will take damage, but that damage is modified by their armor. So we have an example here. So we have a fighter named Conan with a combat rating of 10. 2 points of armor and 5 attack dice, meaning that when he attacks, he's going to roll 5 dice. And his opponent is equally matched. So, step 1, Conan has 5 attack dice. You use random number generation to roll 5 dice, add them together. So he has an attack roll of 22 by rolling 5 dice. He's got a bonus based on 1/2 of his combat rating. 1/2 of 10 is 5. So 22 plus 5 is 27. That's his total attack. Now I don't show the same thing for his opponent, but his opponent's attack is also calculated and winds up being 32.
How does he do that?
How so? What?
How does he get a 32?
It would be the same mechanism, except he rolled higher numbers.
Except
If you want me to give a second example.
Except he's got 5 6-sided dice.
He has lots of dice.
Yeah, he got lots of 6s.
It's still only 30.
He cheated. No, yeah, but then he gets his challenge rating add on it, so that's 5.
Oh, okay.
Yeah, so it's possible for him to get there.
I didn't see
Just roll with it. I could just say his opponent doesn't have equal stats, but it would be the same thing. Yeah.
Okay.
So his opponent's total attack is also calculated with really good rolls. Okay, anyways. Say that it winds up being 32. Very good question, actually. So the attacks are not equal, so the round is not over. If that was equal to that, then yeah, it would just all be over for that round. So you calculate the raw damage, which is the difference between his attack and his attack. 5 points. Then you calculate real damage. Conan rolled less, so he's going to be taking the damage, but he's got armor. His armor is 2, so 5 minus 2 is 3 points. So the real damage is greater than 0. Conan would take damage. He takes 3 points of damage, and his rating drops from 10 to 7. It keeps looping until one of them dies, or gets to 0. You could just say he's defeated if you don't want to be, violent about it. And the way it's rigged is that since you get a combat add, a bonus based on your challenge rating, and your rating decreases whenever you take hits, very quickly, once one of them starts losing, he loses very quickly. It's just kind of the side effect of that. But if their armor is too high, they'll never take any damage. What if his armor was 10? Then, you'd have to somehow come up with more than 10 points of damage in order to overcome that armor. And if the armor is larger than the maximum value of damage that could be generated by the system by the number of dice you're rolling in your combat adds, then it'd go forever. And so that's what the last page is about. So I given a sample output. You don't have to make it look like this. You can make it more terse. This is just showing all the dice rolling together and the CR bonus for 22. So you have 2 characters here, equally matched. They fight for a while. The first time, his opponent wins, and Conan takes 2 points of damage, drops to 8. For round 2, they both roll the same exact thing. Nobody takes damage. Round 3, Conan takes 2 points of damage, just like he did here. Round 4, they fight, but Conan makes a huge rally. And this actually happened. This was sample output from my version of the program. Trogdar's armor absorbs 1 point, so Trogdar is hit for 7 points. His CR is now 3, so he's at a disadvantage. He gets a smaller bonus on his attack than Conan. So, round 5, Trogdar is defeated. And so then there's a little history down here showing what, whoops, should have been 5. For round 1, 2, 3, 4, and 5, what happened is we saw Conan take a couple of hits at the beginning. I guess it'd be neat if we showed the total ones, 10 stars, because he had 10 points to begin with. But then immediately he lost 2. He lost a couple more. Trogdar remained triumphant until round 4, where he took a big hit, and then in 5 he was defeated. So you don't have to implement this, but you can do it. You just use lists. Y'all already know everything you need to know in order to do this, because all it is loops and random numbers and if statements and math. So go ahead and read the document a few times. I'm sure that the veteran game players already have, locked in. So it's worth twice as much as a normal program, so it's very well worth doing. If you don't want to do this and you want to do a different project, like I said, write it up, drop it in the folder. Write your submission up, drop it in the folder, text me a message, I'll read it, and I'll go, yeah, that's what you're going to do. Does that make sense? I see some hits either shaking no or they're sleepy, but I hope it makes sense. Come talk to me if it doesn't. All right. I just wanted y'all to have a slightly bigger program than, okay, add 3 scores together and print the output, or that kind of thing. I wanted y'all to have something fun to do. The C# class gets to do an elves versus orcs battle where they have arrays of elves and arrays of orcs, and then you fight the arrays until somebody, until all of one team or the other's wiped out. Kind of a similar idea, but the combat is more easily resolved than this. But this isn't that complicated. Alrighty, guys. Hope that makes sense. Y'all have considerable amount of time for it. Don't put it off until the last week. The reason I gave lots of time is for those who want to do different projects. We can have time to communicate about it. All right, what are we going to do next? talked about dictionaries. We've talked about tuples. I think we are almost done with the online textbook, which means we are also almost done with the actual textbook. I don't know why this says. I need to give y'all a better assignment over dictionaries than just this one. That's one. As this is chapter 8 of the actual text. This makes it look like we're done with the chapter. No, we're just going to be done with the Python section of the actual chapter pretty soon. Then we may veer off into topics that aren't covered in these texts. But we definitely need to cover GUI programming, graphical user interface programming. And then if we hit any other topics, cool, and then we're going to flip over to JavaScript and CSS, cascading style sheets, web development rather than Python. So the end is near for our Python journey here. We do have more material to cover though. I liked how you snapped on that right away because you knew that 6 dice times 5 is 30, so how in the world did he get up to 32? Very good question. Okay. All right, holy moly, are we already done with this entire textbook? That's impossible. So we're going to hit chapter 10 again. What we learned is that a tuple is kind of like a list, except the values are immutable, meaning they can't be changed. And really, that's all you need to say about tuples, come to think of it. So if you print out a tuple, it prints it out in that format rather than the square braces. Parentheses are how you declare your tuples.
You said it can't be changed.
Exactly. You can build a new one. Okay, let me complete your question.
Extended in any way?
No. No. Right. So tuples.
It is locked. Once you create
Yeah,
it, it's
yeah.
locked. Okay.
Exactly. You can add two tuples together, I believe. Once created. Once created, you can't change elements. You can't append or delete elements from it. Let's find out if you can add two tuples together to make a larger one.
At the end of
My hunch is no, but we're going to find out.
at the end of the video, you would really use the same name, but replace the first value and then pull values from the original one.
Exactly. That's how you could build a new tuple that had a modified value, would be to pull out the variables that you wanted to maintain the same. Let's play with
What
it.
I didn't get is you use the exact same. You change the table, it doesn't matter what the variable is.
I reassigned it to the same variable.
You did.
Is that what I did?
Yeah.
Which is okay because, I could have assigned it to a different variable, but the whole thing happens and then it goes across the equal sign into its new destination. And whether that new destination was the original variable name or a new one. When we say immutable, it doesn't mean that the variable can't be reused for something else, because Python is loosey-goosey and lets you use a variable name for anything you want at any time.
It was just confusing from a standpoint of what point does your pulling from the first one start to
Affect
reach
it.
into overlap.
And just think of it
You just
as,
answered it. You pull everything and then you write it to the variable, so okay.
right, think of the left-hand side as not even existing until the entire right-hand side is done. And then something happens. Okay, so I'm just doing this in the shell right now to find out if I can add together two tuples. C is equal to A plus B. Well, what do you know? Now print out C. So you can combine tuples, just like you could combine lists. A is equal to you know, 1 comma 2 comma 3, which is a list. B is equal to, 4 comma 5 comma 6, which is a list. C is equal to A plus B. Print out C. If you want to do something like weird, C is equal to 5 times A. The result may be counterintuitive, but look what it did. Just kind of like with strings. 1, 2, 3. 1, 2, 3. It appended 5 copies of the list together when we multiplied it by 5. A little odd, but it works. So if we have a tuple that looks like this, and this is just what we were talking about in our question, 10 comma 20 comma 30, and then we wanted to change that first value, here's what we could do. We could say B is equal to, and then we could modify let's try to change, if we print out A0, we're going to see that it's 10. A1 is 20. A2 is 30. But if we do A0 is equal to 100, that's going to give us an error. The error is tuple object does not support item assignment. Can't copy a new value into it because it's immutable. And strings, by the way, are the same thing. Same way. You can't change a single letter out of a string in this language, unlike some others, like C. So instead, we would do something like this. I'm going to create a new tuple, which consists of the old tuple, but with a modified first value. And there may be a different way I could do this, but I can't think of it right off the top of my head. So 100 is our first value, but then we wanted our second value and our third value to remain unchanged. So now if we print out C, it's going to be equal to 100 comma 20 comma 30. And then if I did not overwrite the original value of A in that case, but if I wanted to, I could then do A is equal to C. And now A and C, are referring to the same tuple. So they both have the same values. And last Thursday, on Tuesday, I demonstrated it by putting an A there. So A is equal to value, comma, A sub 1, comma, A sub 2. So what happens is that entire side, the right-hand side of the equals of the assignment, gets all processed first, and then that result gets copied over the equal sign and stored into C. So it would create a new tuple with these values in it. And the old tuple is just kind of pretty much gone at that point. Python supports the idea of garbage collection, which is that once nothing is referencing that data anymore, which is true after we do this, we don't have anything that equals 10, 20, 30 anymore at that point, then it's cleaned up so that your program just is not holding on to that memory. A memory leak is when a program allocates memory while never releasing it, and it grows in its memory requirements over time, using up more and more memory. Yeah. Fortunately, Java, Python don't do that. Or I shall say they attempt not to do that. C# is kind of halfway there. If you use some of the libraries, they do their own garbage collection, and then if you're doing other development, you have to be very careful to delete whatever memory you have allocated. If you have a loop that's allocating memory and then never freeing it, it's a real problem. Not in this language. Mostly it's taken care of for us. I can't ever recall when I ran into something with Python that I was worried about in that fashion. Comparing tuples. You can compare them, and the way it works is it compares the first value to the first value, and it compares the second value to the second value, and the third value to the third value. Now this makes me wonder if lists can be compared in the same way. I don't recall seeing that before. So I'm going to do new file, save as, today is November 2, go to my scripting directory, November 2. I'm going to just call it L1 for list 1. and it's going to equal 1 comma 4 comma 9. L2 is equal to 2 comma 4 comma 9. Can we compare them? B for Boolean value is equal to L1 less than L2. And according to those tuple rules, L1 is in fact less than L2 because all the elements are less except for that one. And that one's smaller than that one. I'm going to print out B, see what happens. Is this a syntax error? Is it going to work? We'll find out. It is true. Let's test this by swapping that 2 and that 1 or something. Let's make L1 have a larger third element than L2. And it's false. Okay, so you can compare lists and tuples in that fashion, which makes sense because a tuple is just an immutable list, in my opinion, in my brain. What happens if the first and the second elements look like this, where L1 has a higher value in the second column, but L2 has a higher value in the third column? Is L1 still less than L2? No. L1 is greater than L2. It first checks that value, then it checks that value, then it checks that value. Just kind of like our numbering system, right? Where you have hundreds, tens, and ones. Tuples work the same way. So here, we look at this code. They have a string, but softwood light, yonder window breaks. Then they split it by spaces because they don't specify the delimiter. So words is now a list. And then they create a new list. And this is kind of odd to me because what they are doing is they're building a new list that just consists of all the elements of the original list appended onto it. But at that point you do at least have 2 identical lists, but they're not the same list. What do I mean by that? I've already told y'all that you can have 2 references to the same data, right? Just like 2 street signs pointing to the same street. By creating an empty list and then appending all those values, you wind up with 2 different ones. Let's print the list. I don't expect y'all to type this. Print the words, but softwood light and yonder window breaks. Yeah, okay, it's doing it in reverse order though. Yonder window breaks, light, soft, but in. No, actually it's not in any order at all. Why would that be? This says it's sorting them from longest to shortest. Oh. Append based on the length of the word, followed by the word itself. You know, I'm not going to spend a lot of time trying to figure out how this is working, because I'm not spotting it immediately. But what does append do if you use 2 values rather than 1? That's my question in looking at that code. Python 3 append list. I'm going to go and find that method in the Python 3 instructions. Append x, which takes 1 argument. Well, let's play with it. Let's play with it. Let's go back to our code. It's always educational just to kind of flounder around. Let's make an empty list. L is equal to empty list. Let's start appending things to it. L.append 1, comma, hello. L.append 3, comma, goodbye. L.append 2, comma, No, I should be using words that all are in sequence. So how about Abe for the first one, Bob for the second one, Charlie for the third one. And now I want to append back into one something that starts with a D, doggy. Then I'm going to print L. And I'm going to see what the results are. Blows up. Append takes exactly one argument. Oh yeah? Then what were we seeing over here in our lecture? Oh. They made a tuple out of it. That's what they did. Doesn't look like one, but they did. So let's turn these into tuples by enclosing them in their own parentheses. Like that. So you see what's happening. Each one of these is an item getting appended to a list. So we are creating a list full of tuples. That works. But when we print them out, we get this 1 comma business, 3 comma business, 2 comma business, and 1 comma business, just like I would have expected. They got appended in order to the end of our empty list. Going back and looking at our code, after we appended all of the words and we printed out our words, we didn't see any of that business. And I don't know if that's a difference between what the Trinket Python is and our Python is. Let's find out. I'm just going to take this code and paste it into Trinket and find out. Maybe it's because they declared their list like that. We'll find out real soon. I'm going to put this up at the top. Run it. Alrighty, fine. Let's create our list like this, mimicking their syntax exactly. Nope. Alrighty. They sort their temporary list right here. So I goofed. I didn't print out. We were appending to a list called T, but then I printed out something called words rather than a list. So I should have printed out T. Let's see how that looks. Alright, that did it. That did it. My belief in the sanity of that world is correct. Is what I was being confused by is I thought that when I printed the list out, I was getting something that was not tuples, but it turns out to be tuples because I was printing out the wrong thing. T is a list full of tuples, and I was printing out words, which was the original split version, not the modification of it. Then they reverse it. Then they make a new list. They iterate through the list of tuples. And this is a good syntax to learn. So despite our floundering around like a fish here for a moment, I really do want y'all to know this for syntax. So we're going to use that. Let's create some tuples. T1 is equal to, and we're going to put different types in it for some reason. T1 is equal to Bob, who's 31 years old and goes to Rose, very similar to an example we did previously. T2 is equal to Joe, who's 40, goes to OSU. And then T3 is equal to Sue, who's 28 and goes to OU. Now we're going to add all three of those to the list. Let's make a new list. There. Now we have a new list, just like always. Textbooks seem to like doing it like this. L is equal to list, like that. I don't see the advantage of doing it that way. There may be one. Okay, so L dot append T1, L dot append T2, L dot append T3. Now, previously, if we wanted to iterate through a list, we would have done something like this. Don't type this because I'm going to revise it. For every element in list, print that element. We would have done that, but it's going to print 3 tuples. Maybe that's not what we want. Maybe we only want the first names to be printed. So instead what we're going to do is we're going to say for every name, comma, age, comma, school in L, print out their name. And it printed out Bob, Joe, and Sue. So we are able to access the individual elements of the tuple like that. Similarly, what if we had some coordinates in an XYZ system? You know, this guy was at 10, negative 20, comma, 5. Those were his XYZ coordinates in outer space. You could say X, comma, Y, comma, Z is equal to that coordinate. Then you could print them out. You know, print X, print Y, print Z. And so X was 10, Y was minus 20, and Z was 5. Now this syntax here, you will not see in a C-based language like C++, C#, or Java. Kind of why I'm hanging out and letting y'all look at this for a little while. Because if you've taken one of those languages, this is different. You don't get to do it that way. What do I mean by that? Your for loop doesn't iterate, give you 3 values at once. Python's a weird thing, because if you did this, X, or A comma B is equal to 10 comma 20, yeah, it likes it. It puts 10 inside of A and 20 inside of B. And then if you do B comma A is equal to A comma B, it flips them. After that, B is equal to 10 and A is equal to 20. And I've never seen another language that does that. Just, it's interesting to me. Another implication of that is you can write a function which returns more than one value. Let's do that. We're going to write a function. It's just going to be a test function. But def get student, colon, and it's going to return a student's name, Susan, her age, 19, and her school, Texas University. Now when you're ready to call that, you could say name, comma, age, comma, school is equal to get student. You could print them out. Or you could just trust me. By the time we're done, name's going to equal Susan, age is going to equal 19, and the school is going to be TU. Isn't it really UT? University of Texas. Alrighty. True, TU, Tulsa University. Alright, I didn't change anything, so it didn't print out anything different. So in this language you can return more than one value, which is quite a bit different than the C-based languages, including Java. What if this was a list rather than a tuple? Would it behave the same way? And since I've already claimed that a tuple and a list are about the same thing, except that the tuple is immutable, I'm going to say yes. And it turns out to be the case. So you can pull 3 bits of data out like that. Now, do you always know that a list is only going to be 3 items long? Well, if you write your program, you do know. But maybe that's why they don't show you that until they get down to the chapter on tuples, that ability to pull, multiple items out of a list like that. But what's the drawback of doing it like this? What if there were more than 3 values in it? Whatever. Don't type that. Or I don't care if you do or not, because how do you get 10 out of it subsequently? How do you get 203 out of it? And the answer is you really don't. Unless you do this. Yeah, no, you could say A is equal to coordinate, like that. And I think I have the wrong number anyway, 0, 1, 2, 3. But it's nowhere as clean as doing it that way, right? So this kind of makes sense for tuples, where you're assuming that you know the length of the tuples because you're creating them, you're defining them. Okay, my tuples are going to be 3 values, a name, an age, and a school, or an X and a Y and a Z, or a color and a radius, if we were drawing things on using turtles or something like that. Dictionaries and tuples. Dictionaries have a method called items that returns a list of tuples where each tuple is a key value pair. Let's play with that a little bit. We're going to flip back into dictionary mode for a minute. I'm going to make a dictionary just called capital D. D is equal to DICT, and I'm going to add a few things to my dictionary. Sue's age is 23. We probably said something elsewhere. Whoops, I botched that syntax. Sorry, guys. Sue's age is 23. Or let's use 2 strings. Her favorite color is red. Bob's favorite color is orange. And Jim is a goth, so his favorite color is black. Now, if we want to pull all that data out in one fell swoop, we can use d.items. Firstly, let's just print d.items and see what it returns, even before we build a list out of it. Oh, this is Python 3. I need parentheses after my print statement. Alrighty, so you see what it did. When I said items, printed it out, it's got this list made out of pairs like that. So we see the entire dictionary represented as a series of tuples when we do that. I think we're seeing the underlining structure and how dictionaries are stored, except I also know that dictionaries have hash values. We talked about that so that they can be accessed very quickly. We could create a list based on those items. Their example is T is equal to list based on d.items. And then let's print T out. And it's going to look just a little bit cleaner than it did before. It's going to remove this stuff. It's just a flat out series of tuples now. Now, if we wanted to print out their list of favorite colors, it's pretty easy to do that. For every name, comma, color in our list, why did I use T for list when I use L everywhere else? Anyways, then print out that color. And we should see red, orange, and black, although not necessarily in that order, because these are values, and in no way are dictionaries sorted by values. Alright, but in this case they are. Red, orange, and black. I wonder how many we would have to insert before they became no longer sorted by the order in which we inserted them. Maybe an infinite number. I'm not sure. What if we just did for every name, comma, color in the dictionary? I'm going to change that to a D and see if it does the same thing. Yeah, I didn't expect it to. It did not fail me. Undo that change, leave it a T. So coming back to our running example of writing a program that'll pull out the text from Romeo and Juliet, we can augment our program to use this technique to print the 10 most common words. This is very similar to what we did. Remember when we wrote a program that would calculate the most common letters in a string and it counted them? That's what this is doing, except it's counting the entire series of words. But then they want to sort them by their value, the value being the count, right? Because our dictionary consisted of the letter followed by the count, and they're doing this rigmarole to sort it by the value. And then they could print out the last 10 items in the dictionary, the last 10 items in the list to get them out. I don't know if we really need to do that, but we could. Why don't we sort our list by the colors? This isn't, we can't translate this immediately into our own version of the code because they're actually keeping track of two different things. Not really.
I just used line 19 and it went.
Okay, yeah. Okay, so what did you do? Did you just...
Line 19, I did T dot sort with reverse equal true, and it did.
Okay, let's do that.
I actually put it in front of the print T at the bottom.
Good idea. So we don't have to print it a second time. T dot sort, reverse equals true.
I actually put it above the print T.
And this sorts them by their name, not by the value of the, it sorts them by the keys.
No, I did it above the parentheses T, and it won't. Not above the for loop.
Oh yeah, yeah, okay. I see what you're saying. So this way we get to see that the names are in fact, well, why don't we just print out their names as well as their colors? You know, print out name plus loves plus color, and then we're going to see that the names are in fact sorted, which is what you were seeing when you did the print T right there. But they are in reverse order. Sue, Jim, and Bob. If you don't want them reversed, you take that reverse equals true out. Or change it to false, but you just take it out. All right, and then we get Bob, Jew, and Sim. Bob, Jim, and Sue. They're going to a little bit more effort here because they wanted it to be sorted based on the values, not the keys. And we sorted it by keys. And do you see how they do that? They take the keys and the values out, and then they create a new list which consists of those things reversed. Values sorted by keys. Let's play with that. Let's make a new list where all of our tuples are reversed. So for every name, comma, color in T, wait, we don't have an empty list yet. I'm just going to call it T2. I'm not feeling creative. For every name, comma, color, and T2 dot append, parentheses, and inside of our parentheses we're going to create a tuple that consists of color, comma, name. Then let's just print that out. We could reverse sort it, you know. Yeah. Let's sort T2. T2 dot sort, and it will be sorted by its colors. So black, orange, and red. Since these sorts are dependent upon the order in which they are declared, I honestly don't know a way that you could say, okay, sort this data based on the second field, the second column, or the third field. And that's what makes databases powerful, is that you could say, okay, I want you to select all the records that match this criteria based on this sort, based on this sorting of the second field. And it'll suck that in. And it's probably true in Python, I just haven't researched how to do it. We see here that in order to sort by the second value in the dictionary, we actually had to create a new list, you know, a new list that was composed of, you know, those items flipped so that the first one could be sorted on, color could be sorted on.
Can we see your output?
Pardon me?
Can I see your output?
Yeah. Is it looking weird? What are you seeing in it? Is it looking different? Yours, I'll pause, come look.
It's different. Yeah.
Using tuples as keys in dictionary. Yeah, since you can put anything as your key in a dictionary, tuples could be a key. You could also insert tuples as the values in a dictionary. I guess that's worth playing with, and then this will be about the last thing we do with tuples. Way up here, we had 3 students, right? T1, T2, and T3. Go ahead and just copy that code, that T1, T2, T3. I think I reused the names T and T2, so I'm wanting to reassign them. Scroll down to the bottom and paste those things. And let's insert those into a dictionary. Called students. Students is equal to an empty dictionary. And now we're going to add those guys into the dictionary based on some imaginary student ID. 1, 2, 3 is the first person's ID, is equal to T1. We have another student ID of 4, 5, 6, and that corresponds to student T2.
Shouldn't it be students, not dick?
Yes, it should be. Thank you very much. These words should have been students. And if I'd made it a single letter value, probably wouldn't have botched it. Alright, and then students, we have one more student ID, it's equal to T3. Now, how about we write a little loop asking the user for student IDs. If we find it, we print out the tuple that corresponds to that key. Otherwise, we print out an error message. So while true, string is equal to input student ID to look up. Let's convert it into an integer. ID is equal to the int version of that. If we were being really careful, you know, we would validate our input to make sure it didn't crash. Now we need to make sure that that key is in the dictionary. And I've totally spaced on that. Do y'all remember how to check to see if a key is in the dictionary? Because if we don't do that, it's going to blow up.
Can you just do ID and student?
Thinking we can. Let's find out. So if ID is in students, let's print that student out. Print students for the ID key. Else print student not found. And I didn't make this one of my or -1 to exits. I guess I will right now. Student ID to look up or -1 to quit. So here, after we check for their ID, if ID is equal to -1, colon, break. I'll bring the code back up. In just a minute. Okay, 1, 2, 3 was Bob. 2, 3, 4 should not exist. 4, 5, 6 does exist. 7, 8, 9 does exist. 0 does not because that's not a key. -1. Okay. That's just showing that a dictionary can be composed. The values don't merely have to be strings or ints or whatever. They could be lists. They could be tuples. You could have a dictionary full of dictionaries, although my mind kind of rebels at that thought. You could have a whole bunch of students with test scores, you know. Test scores 1, 2, 3, and you could have a string or a list full of test scores. And then test scores 4, 5, 6 is equal to a different series of test scores. Like that. So why do you use dictionaries? When you want to be able to retrieve the data very quickly based on a key. If you're just going to be processing the whole shebang from top to bottom, you shouldn't use a dictionary, right? Because you're not just pulling out pieces of it, you're trying to process from beginning to end. In which case you probably just use a list. Alright, now I want to talk about recursion. Recursion is when a function calls itself. And I'm going to go up and I'm going to add this to the top of our program because, you know, whenever we add input and we have to type things in order to get it to stop running, it's always annoying. Define rec for recursion. Print hello and then call yourself. Alright, now we're going to call our recursive method, our recursive function. This isn't real good. It's like an infinite loop, except it's going to actually crash, whereas infinite loops do not. If we let it run long enough, it blows up. Maximum recursion depth exceeded. Now why is that? Because every time you go into a function, it has to allocate a little bit more memory to keep track of where it is. And then you go back into that function again, and you go back into that function again. That memory is never released. So there's a certain amount of memory allocated to what's known as the stack, which handles the recursion depth, and we exceed it by calling ourselves. So that's a dumb example of recursion, but there are worthy examples of recursion as well. Unfortunately, they tend to get complex rather than simple, but we can write some simple algorithms in terms of recursion. So say we wanted to calculate the total of all the numbers between 1 and 100. That would be pretty easy to do with a while loop, right? Total is equal to 0. We would need a counter. We should probably just use a range statement. For x in range, we want to go up to 100, so we're going to make it 101. Total plus equal to x. And then if we print total was, comma total, we find out, whatever it equaled. That's a linear approach. It's a non-recursive approach to calculating a sum. It's a perfectly good way of doing it. If you implement this using recursion, you're doing something a little bit different. You're doing something called functional programming rather than what we are doing now. But we can do that. Let's write a function which calculates the summation of a series of numbers. So it's going to look like this. Define summat for summation. And we're going to pass in a limit, like 100 or whatever. And what we're going to do is return that limit plus the summat of limit minus 1. And this is also an infinite loop, infinite recursion, so it's not good enough. But you would call it like this. Total is equal to summat 100. And then if we print it out, recursive total was, or is, yeah, whatever, total, like that. But why do I say it's an infinite loop? Because there's nothing that ever stops it. There's no return statement that doesn't involve calling itself again. So when you have recursion, you need two cases. So recursion, your function has to have two cases. A base case, which returns, and a recursive case, which calls itself. We have implemented the recursive case here. For fun, let's add a print statement in here and just watch it run. Print summat, comma, limit, like that. When we run it, we're going to see that indeed it never ends until it runs out of O. Let me get rid of that first function, okay? In fact, you can delete it. DEF, rec, or just comment it out, whatever you feel like doing. That stuff needs to go bye-bye. I'm going to select it all and choose comment out region. There, now it's gone. But this one's not much better. You see that? I wanted to add up all the numbers between 100 and 1, but it kept going negative. How do we stop it from going negative? We go to our recursive function, and if the limit is not greater than 0, so if our limit is less than or equal to 0, return 0 out of it. That'll stop it from going negative. If we were going to put comments, this would be the base case. And this would be the recursive case. So it got all the way down to sum at 1, and it figured out that the recursive total was 50-50. Which sounds right. If I scrolled all the way back up, we'd see that the non-recursive total, the linear one, was also 50-50. So that illustrates it, but it doesn't show you why you would want to do it. Let's use recursion to do something a little bit more interesting than just adding up numbers. Let's go back to turtles and play with making recursive algorithms for turtles. I think it's about time to start a new one. So let's do File, New. Oh, do you need to see anything in here first? Time-wise, we are done. No turtles today. Okay, guys, why don't we stop the Dropbox? Make the Dropbox here. Thank you. I would have kept lecturing until 8:30.